Welcome, everyone, to Challenger Conversations number 2. My name is Peter Tuddenham from the College of Exploration, which is a not-for-profit here in, not here, I'm in Spain at the moment, but we're in Northern Virginia. And for the last 30 years, we have focused on systems approaches to learning with a strong emphasis on ocean literacy, ocean science education, and project and program evaluation. And we are the co-organizers of these Challenger Conversation series with the Scottish Association for Marine Science and the University of Illinois and its
Oops, I'm not sure what everyone else is hearing, but Peter might have frozen for a moment.
Yes.
So as the co-host, I will take over for a moment and hopefully Peter will join us back in a moment. He is in a hotel in Spain. So my name's Hermione Cockburn. Peter, I think you're back with us now. You've just frozen. Do you want to pick up where you left off?
I will. I make a yes. I mean, obviously this. I'm in a hotel in Spain, and obviously something just happened to the internet, which it does. But yes, let me try picking up. And I was at the University of Illinois. So we're working together to plan and implement the series to recognize the anniversary of the Challenger voyage, 150th year. And just a quick nod to Gwyn Griffiths and the National Oceanographic Centre in Southampton, where we first learned of Challenger work, and we worked with him many years ago to do the first Challenger online program. That was really a lot of fun. I would also like to say that SAMS and the University of Illinois have created a data-rich website with all the data from Challenger expedition, and you can find that link on the HMS Challenger.org website and also on the SAMS website. I'd like to warmly welcome my co-host for this conversation today, Hermione Cockburn, and of course welcome our guest speakers and conversants, Laura Trethaway, an ocean journalist and author of The Deepest Map, published this year, and Steve Hall, who is a long-time colleague from the National Oceanographic Centre days in Southampton on ocean education topics, who is now head of partnerships for Seabed 2030. So we'll hear from each speaker for 10 minutes and then start the conversation. Please use the question and answer button at the bottom of the screen for questions for the speakers, and use the chat function to share resources and links. So that's my introduction. Over to you, Hermione.
Well, thanks so much, Peter. I'm glad the internet's got you back again. Hi everybody, and thanks so much for joining us this afternoon or this morning, wherever you are. As Peter said, I'm Hermione Cockburn. I am the scientific director of a science centre and planetarium in Edinburgh, Scotland, called Dynamic Earth. And Dynamic Earth is an educational charity, and we exist to empower people with understanding and empathy for our planet. And I am particularly delighted to be the co-host of this Challenger conversation for 2 reasons, really. Firstly, because Challenger and the history of deep sea exploration has such strong connections to Edinburgh. Of course, Charles Wyville Thompson, the chief scientist on Challenger, was an Edinburgh-based scientist, and a lot of the data and information that led to Challenger becoming a thing was based on his early exploration of the west and north coasts of Scotland into the deep North Atlantic there, where he discovered all sorts of exciting life and changes in temperature that kind of led to some of the main scientific objectives of Challenger. So that's a real historical connection that it makes me a Challenger enthusiast. The other reason is that here at Dynamic Earth, we've just opened a new exhibition called Discover the Deep. And it's a public exhibition. You're all welcome to come and see it if you're passing through Edinburgh. And we've used the Challenger story as a way into the ocean story for our visitors and groups that we work with here. And Discover the Deep is about helping people feel connected to the ocean, understand a bit more about how we understand the ocean, how we come to understand the ocean, what's in the ocean, and why that is important. It's an ocean literacy project, first and foremost. And in that context, I know that I'm going to very much enjoy Steve's presentation, and I have very much enjoyed Laura's book. So without further ado, I'm going to introduce Laura as our first speaker. Just to show you, I have got your book, Laura. I very much enjoyed it. And I hope, Laura, feel free to sort of embellish your introduction. I mean, I know you as an award-winning environmental and ocean journalist and author of another book as well, The Imperiled Ocean, Human Stories from a Changing Sea. This book, it's quite new, I understand, and we're lucky to have you in person now to give a presentation based on the content, and then I look forward to picking up with you afterwards. So over to you, Laura.
Okay, great. Thank you so much for that introduction, Hermione. That was wonderful. Yes, the book did just come out in July from HarperCollins, and I believe you can get it in the UK and internationally as well. So I just want to say thank you first to the Scottish Association for Marine Science for inviting me, the College of Exploration as well, Peter Tuddenham and Hermione, and Anushka Miller from SAM, and Gillen Woods from the University of Illinois for organizing these talks. I'm just going to share my screen and get up and running here. Okay, great. So as Hermione mentioned, I'm an ocean journalist, and I'm going to talk a little bit about how the Challenger expedition turned up in my new book, The Deepest Map. So that's a picture of the deepest map up on the screen there, the new book. It's also behind me, just in case. And yes, it just came out with HarperCollins this past summer. And the deepest map follows SEBA 2030, which is this global initiative to chart the world's seafloor. So this last mysterious, uncharted frontier on the planet, really. And this book actually started while I was writing my last book, The Imperiled Ocean. And I was sort of procrastinating on writing that book. And I found out
Oh, now, I'm not sure the same for everyone, but has Laura frozen?
Yes.
Yeah. Oh, what a shame. Perhaps Laura will come back just in the same way that Peter did.
This is unusual.
It is. Let's not panic yet and just give it a moment. Laura may be doing a frantic restart potentially, or maybe it will just a blip. Okay, it looks to me like Laura may have left the webinar to come back in potentially. Peter, what do you think? Shall we put Steve on the spot and ask him to jump in with his presentation?
I think we are on a doing this in 1 hour, and so it may take her a while to come back. I don't want to keep everybody sitting here, so. Yes, let's switch it around. And Steve, who I've known for many years from his work in England and around the world, I think we started off collaborating when you were at Southampton, as I said earlier, Steve, and then you've had a number of different exciting endeavors, particularly with the Society for Underwater Technology. And you've been a great supporter of education, helping not only the MC, the European Marine Science Educators Association, and our work at the College of Exploration. And now you're doing this great work of encouraging the ocean mapping process with SEBA 2030. So please, why don't you take it away?
Okay, thanks very much, Peter. And for those of you who've been around for a little while, Peter and I probably first worked together back on the Jason project some years ago, and I can see Gwyn Griffiths there in the audience, and Gwyn, Peter, and colleagues were some of the first people to actually use video conferencing in any way, shape, or form to try and transmit this knowledge across the globe. So a good heritage there, Peter. Right, I'll just share my screen. We were hoping to have Laura up first, but not a problem. We'll do mine initially. Okay. Right. So I'm going to talk to you a little bit about Seabed 2030, which I very much feel is the kind of project which is building on Challenger's legacy. And also very pleased to say, bearing in mind the association with SAMS in this call, that the Scottish Association for Marine Science signed a new MOU with us just a couple of weeks ago. So they're one of our bright new hopes within our ocean science community. Deliberately on this introductory slide, as well as the picture, of course, of Challenger, I like to use the image of the Spielhaus projection. It's sat there on the left of the slide simply because it does such a good job of helping to get across to the viewer that it really is one planet and one global ocean. And if you look at that thing really closely, you'll see that amongst the darkness of that single global ocean are all those little pale tracks, little pale lines, and those really are the parts that have been surveyed. Often it is great circle routes between seaports, between islands, between the places where ships are based. A lot of the mapping tends to be at places where there's some kind of industrial activity, such as oil and gas developments. It tends to be places where we're extracting fish resources or dredging. But first and foremost, seabed mapping has always been about safety and navigation. So bear that in the back of the mind. It's I suppose legally, the reason anybody pays to create hydrographic charts on maps is to make sure ships don't run aground. So that's always where things start from. So you have Challenger conducting her global exploration in the late 19th century, and it very quickly became apparent how limited humanity's maps of the seafloor actually were. And in 1903, Prince Albert of Monaco pulled together a project which became the General Bathymetric Chart of the Oceans. Oh, great. We've got Laura back. And so I won't dwell too much on this in case Laura's going to talk about these maps within her one. But the first edition of the GEBCO chart barely even included major features such as mid-ocean ridges, because these things really hadn't been mapped at the time. And so through the various editions of the General Bathymetric Chart throughout the 20th centuries, it got better and better. But even today, you could hide quite large countries. I won't do the usual one of saying you could hide Belgium, because poor old Belgium always gets it. So let's say you could hide Wales, where I live. You could hide Wales quite happily in a map of the global seafloor, and it would sit between the areas that have been surveyed. So you can miss quite significant areas of seafloor. So in that first nearly 120 years of operation of the GEBCO map, the amount of the global ocean that had been mapped to modern standards was only up to about 6%. So in 2016, at the Forum for the Future of Ocean Mapping, the Nippon Foundation proposed being able to fund a project in collaboration with the General Bathymetric Chart of the Oceans to be called Seabed 2030. And this is where we are now. So it was launched in June 2017 and became an endorsed UN Ocean Decade program in June 2021. And Seabed 2030 is very much intended to be an accelerator to fast track completing the GEBCO map. As I said, we only had 6% in 2016. We're still only up to 24.9%, so still quite a lot to do. But compared with 6% in the first century or more, it's not bad actually to get from 6 to 24.9 in just 6 years. But obviously there are still 3/4 of the ocean map left to do. And when you look at seabed maps, as you might have seen on that Spielhaus projection right at the start, the places where we have data tend to be where ships go, and naturally. And then once you get away from those great circle routes or get away from areas of economic interest, you quite quickly find massive gaps in the shape of the seafloor. Now, to complete the task is not trivial. We were at a meeting a couple of weeks ago in Edinburgh where Victor Vescovo of the Five Deeps fame gave a superb talk to the delegates about the work that had been done with his own submersible, the pressure drop, using Kongsberg instrumentation to try and map some of these gaps in the seafloor. And Victor pointed out that if you wanted to actually finish the job, it's about $9.60 per square kilometers to map. So that works out at $2.6 billion to map the last 75% of the ocean. Over 54,000 ship days. It would need 185 years for one ship, or 26 ships to do it in 7 years. So it's a very substantial piece of work left to do. Now, autonomy will be the way that we're going to have to do quite a lot of this work. And it's not a new thing. Scientists have been using drifting instruments for decades. The message in a bottle, it's very low bandwidth. It doesn't transmit many words per hour or words per year, but it's still a method of information. And of course, sea mines, torpedoes are essentially primitive marine autonomous systems themselves. So robots aren't new, but they are the things which have been used to try and fill in a lot of gaps in the information that we have. In this particular montage, we have the examples of the Autosub Long Range from Southampton, a good example of the kind of the underwater vehicle, autonomous underwater vehicle that can do mapping, but inevitably these things are constrained by battery life. Whether it's batteries or hydrogen fuel cells, whatever you use, you tend not to be able to get any more than a week or two if you're trying to do seabed mapping. So very difficult to do long range with marine underwater vehicles. But the surface vehicles you can do a good job with because they tend to have more installed power. You can have solar panels to top up the batteries. You can have a small diesel generator. And so with vehicles like the sail drone, which we show there in the center, or with the Sea Kit devices up there on the top right, it really does let you start being able to mow the lawn, so to speak, and start mapping some quite substantial areas at a much lower cost per day than you can with a traditional crewed survey ship. You can't do it without partners. Seabed 2030 isn't funded to be able to actually go out there and do the surveys ourselves. We completely rely upon having a global network of voluntary help. We're getting the companies like Foodgrow and others to go out there and voluntarily contribute their data to help fill in the gaps. But remember, if you are a private company out there mapping the global seafloor, you're usually mapping for a client, and the client may not be in a position to want to share the data or have commercial value attached to it, or your client might be doing it for defense purposes or whatever. So you can't always share the data, but what you can do is share the underway data while you're on your way to and from the survey area. And so we're doing a good job now on encouraging people to leave the system switched on so we can get transit information as the survey vessels, robotic or with a crew, go out there and map. We're building very good relationships directly with the people that do this. The winning trust does matter, and we're learning a lot of lessons. For example, colonial language. I hadn't appreciated that some of the islands in the South Pacific, for example, don't like being called small island developing states. And our suggested alternative is big oceanic states or big ocean states, just to try and get across to people that these have enormous offshore areas under their jurisdiction. And there's also a significant role for the professional bodies, the learned societies like SAMS, and the other community advocates. Crowdsourcing can be done, particularly in the shallower waters, and also where you have people who take their vessels to locations that are rarely visited by survey ships. And so we're working with industry. Here's an example of one of the data loggers from a company called CID, who will install their equipment, or you can install it yourself into the navigation system on your vessel, and it will use the echo sounder data from your, it could be a super yacht, it could be a cruise liner, it could be a fishing boat, to help contribute data directly into the GEBCO map. What we don't have is the great blessing our friends in the physical and chemical oceanography community have of this global network of floats. I mean, here's a snapshot of the Argo float network from a couple of days ago, and nearly 4,000 of these floats drifting around the global ocean, constantly transmitting back data about the chemistry, the oceanographic parameters. At the present day, apart from a handful of prototypes, we don't have echo sounders built into these kind of autonomous drifting floats. If that kind of technology becomes available in the future, you very rapidly start being able to fill in the gaps. And the other thing we can do is use satellites, aircraft, and drones to gather data as well. They're not able to, from orbit, directly image or measure the shape of, for example, a deep ocean trench. But what you can use is the variations in the Earth's gravitational field to figure out where the trenches and mountains actually are. It's just not necessarily done to a very high level of resolution. But you mix that with even 1950s or 60s paper charts from the cable layers, and you start being able to get some really, really good data. Outreach is vital, so we strongly welcome books like Laura's for getting the message out there that this project exists, and we really would welcome voluntary contributions. And so we get out there, we go to the trade shows, we go to the conferences, and we've recently started a podcast, only 2 episodes so far, but if you Google or look for the Nippon Foundation GEBCO Seabed 2030 podcast, you will find the first 2 episodes. So I will stop mine there so that we can return back to Laura, and she can give us her perspective next.
Thanks very much, Steve. That was great. I really am having to hold back asking a whole load of questions. But the point is also to get questions not just from me and Peter, but from our participants. So just a reminder, everybody who's on the webinar, to use the Q&A, pop in your questions, any type of questions. I've got lots of questions about quality of data, what we mean by engagement, and all sorts of things, and the imperatives to get this map. There's so many things to unpick. But before we start the discussion, I am now going to keep my fingers crossed that we keep Laura for the whole duration of her talk. So Laura Trethui, please could you try again? And we look forward to your presentation.
Yeah, sorry about that. I'm not exactly sure what happened. I'm crossing my fingers too. So let's hope this works and Zoom doesn't kick me out. Just a note to everyone, make sure to update your Zoom. I think that might be the problem. Go. Okay, so I am going to pick up from where I left off. So I was explaining a little bit about how I got started writing the deepest map. And so the deepest map, it follows Seabed 2030. I actually think it's wonderful that Steve went first and sort of explained more about what Seabed 2030 is. I was quite excited about it, quite intrigued by this initiative. But a big part of the book is not only about Seabed 2030, it branches off into this other quest. This young scientist who's up on the screen right now, Cassie Bongiovanni, she is part of the 5 Deeps expedition that Steve also mentioned earlier in his presentation. So the 5 Deeps was this quest funded by Victor Vescovo, who's this multimillionaire explorer, and he wants to dive the deepest points of all 5 oceans for the first time in human history. Problem is that no one knows where those points are. So he hires Cassie, this ocean mapper, to go find them for him. And Victor Vescovo, he tends to get a lot of the glory for diving the deepest points, rightfully so. But it's really Cassie who did a lot of the work behind the scenes, finding him those diving sites to go to. And this is actually a photo of Cassie from a Discovery Channel documentary about the Five Deeps expedition that came out a couple of years ago. And here she is mapping in the middle of the Java Trench. So, of course, a few of the deeps that Victor Vescovo would go on to dive were already known. One of them was first discovered by the HMS Challenger on its expedition around the world. So the crew took hundreds of soundings all over the world, drawing them up laboriously from the deep, and they discovered major geological features like the Challenger Deep, obviously, named after the ship in the Mariana Trench. And Victor Vescovo dove that in 2019 on that expedition. I also want to mention in the Indian Ocean, the Challenger expedition sailed over this very conspicuously shallow stretch of water. And they weren't quite sure what to make of it when they found this. They didn't really know how to interpret it. And something that stuck out to me in the writing of my book was that there was this popular belief at the time that Challenger was going around that these high ridges in the middle of the ocean were actually drowned continents. So when news of the Challenger discovering this shallow section in the Indian Ocean got back to England, the newspapers at the time sort of hailed it as the discovery of the lost city of Atlantis, which I think is sort of wonderful that newspapers are publishing that kind of thing back then. The stuff that they publish now, not as fantastical. So the myth of this lost underwater city, the Atlantis city, it was pretty popular in Victorian science fiction at the time. It held a lot of appeal to readers who were living through the Industrial Revolution in England. This story of a high-tech civilization that sort of wiped out by natural forces. And the public was also sort of primed to accept stories like this because at that same time, the German archaeologist and treasure hunter, Heinrich Schliemann, he had actually recently discovered the lost city of Troy simply by just roaming around Turkish hillsides with a copy of the Iliad. So, why can't we find the lost city of Atlantis too? If Troy exists, why not Atlantis? But as I mentioned, the scientists on board the Challenger were really torn over how to interpret what they were finding. Another major theory at that time was that there was this view of the Earth as fixus, that, like land and sea could not swap places. So land was new Earth, seafloor was old Earth, the sediment washed off the newer, more interesting geology on land, and then it came to rest at the bottom of the sea, which was, like dead Earth. But the scientists on Challenger, they're making all these major geological discoveries. They're finding trenches and ridges and deep sea minerals, but they don't actually have the tools or really the maps to piece together what all this means in their lifetime. So this brings me to another character in the book that I want to talk about. So Marie Tharp, some of you might have heard of her. And Marie really paved the way for female ocean mappers like Cassie Bongiovanni, who are out on the sea today. Marie was a cartographer at the Lamont Doherty Earth Observatory in upstate New York, and she's working during this really phenomenal period for ocean mapping during sort of the post-war Cold War period. And Tharp is really a very curious character for her time. She's a divorcee, she's a single woman working in the sciences. She kind of talks funny, she dresses funny. And she's working at this time when women are not really welcome in the sciences at all. At American ocean institutions, they're not even allowed on the research vessels until the late 1960s, early 1970s at best. At Lamont Doherty, where Marie worked, they weren't even allowed to set foot on the gangplank. And so Marie finds herself in the right place at the wrong time because she's sort of hungry to do all this ocean mapping work. And there's all these great maps pouring in from the Cold War and anti-submarine warfare. And Marie manages to get around the restrictions against her sex by forging this sort of part scientific, part romantic partnership with a scientist there called Bruce Heezen, who becomes her boss, even though he's younger and less experienced than her. And Bruce goes out and collects all the soundings at sea, and he brings them back to Marie, who sort of painstakingly plots them on a map. And so Marie takes all these soundings, and one of the first things she notices is that there's a big ridge in the middle of the Atlantic. and it's snaking all the way down the ocean. And it immediately dawns on her that this is where New Earth is bubbling up from the center, and it's pushing the continents further and further apart. And, today we all know that continental drift is true, and that there was once a big supercontinent called Pangaea. But back then in the 1950s in geological circles, it was really a career killer to believe in continental drift. Scientists who did were called drifters. So it's sort of like calling someone a loon. And so Marie takes these early maps to Bruce, and he groans. He said it looks too much like continental drift. He calls it girl talk. But Marie keeps drawing her maps, and she's finding more and more evidence that the ridge is not only in the Atlantic, but that it's in the Southern Ocean, the Indian Ocean. It's all over the world. It's 40,000 miles in total. And some of the soundings that she's drawing on, here's the link back to the Challenger, are coming from the Challenger expedition in the 1870s. So those early soundings of that shallow section in the Indian Ocean, that's actually a part of the mid-ocean ridge. Something that, in the popular imagination is this like lost city of Atlantis. But, we're finding out that it's something totally different. And then the Challenger also sailed over another section of the mid-ocean ridge in the Southern Ocean on their way back to England. And the scientists on board speculated that this ridge might extend all the way across the Atlantic, all the way up to Iceland, which we now know today is true, that, it does come up onto land in Iceland, and you can actually see it there yourself. And then this map comes out in 1967. This was published by National Geographic, and this is really a culmination of so many different people's work. It's a map of the Indian Ocean seafloor. I actually have it up on the wall behind me too, because I'm a big fan. And it's painted by an Austrian painter, but it's actually based on the work that Marie's been doing for the last 15 years. And this map is really the first modern glimpse of the seafloor that anyone's ever seen. And it remains one of the most popular maps of the seafloor today. And this came out in 1967 at sort of a pivotal moment in the debate around continental drift. And it actually paves the way for scientists and the general public too, to finally accept that, not only is continental drift happening, but this new emerging theory of plate tectonics is true as well, because everyone can see it on the map, that you can see that the seafloor is not dead, boring earth, but that there's mountain chains and there's canyons and valleys, and that the whole surface of the planet is on the move. And it's bisected by all these mid-ocean ridges and trenches. And so Marie's maps quite literally changed the world. And I like to think of the fact that the early sounding work of the Challenger is actually baked into those maps too, and helped in its own way in discovering plate tectonics. And I wanted to tell all these overlapping stories in the deepest map because they really got at this reason for why I'm attracted to maps in the first place, which is that maps are a collective effort. It's really like science itself. And I'm just going to round off here by reading this quote that I have in my book from Dennis Wood's book, The Power of Maps, which is another really excellent book about maps if you haven't read it. And he writes that maps are not a self-contained document, but a compilation of what others have seen or found out or discovered, others often living, but more often dead, the things that they learned piled up layer on top of layer, so that to study even the simplest looking image is to peer back through ages of cultural acquisition. And I really love that quote because that's what I see here when I look at this map. I see years and years of effort and dozens, hundreds of people who contributed to this work. And yeah, I'm just going to leave it there for now. Here's all my contact information if you'd like to get in touch and find out more. And thanks so much.
That's wonderful. Thank you very much. Let's hope my internet holds up. Thank you, Laura, and thank you for such a great and concise story about the Challenger. You've just done a fantastic job. And what came across and has come across from your book, Laura and Steve, is the stories, is the people involved, is so important. I mean, Steve and I have a long-term relationship, and we've been able to work together over many years. And your book talks a lot too, which about women and their role, and they have not been acknowledged, perhaps in ways that they should have been in the work that they did. So perhaps if I could, ask you both a question about people, and you can answer them. I mean, for Laura, I'm interested in why you personally got into this, and those observations about women in mapping, and for Steve, what is it that's drawn you personally into this sort of world of the ocean and mapping it, and the work that you've done over the years? So it's sort of like, if you could tell a little bit of a personal story, I'd appreciate that. So Laura, if you'd like to go first, and then Steve.
Let me make sure my volume's on. So the inspiration for the Deepest Map really came from that story that I read in the Smithsonian, just telling me about Seabed 2030, because immediately I could see a book there. I think I took that article and put it into my book proposal because it was just so perfect. But I think there was sort of a deeper reason for why I was attracted to writing about ocean maps, which is that there's this cliche that you hear all the time in the ocean reporting world. I've been writing about the oceans for, over 10 years now. And there's this quote you hear all the time that, we know more about the surface of the moon or Mars than we do the bottom of the ocean. And as somebody who cares a lot about the ocean, I always sort of got annoyed with this phrase, because I felt like it was always just dropped into stories without any explanation. So it was just, we made a new discovery. Oh, and by the way, we don't know very much about the seafloor. And I always kind of wondered, why is that? And why do we care so much more about outer space, which really has no impact on our daily life? And the ocean is, right outside, and it impacts society in huge ways every day. So that question of, why we care more about outer space than the ocean floor, that really kicked everything off. And then when I sort of dug into that a little bit more, I realized that it was about mapping, the fact that we've mapped the moon and Mars and all these other planets perfectly, and we haven't mapped the seafloor. And so that's really where it started. Okay, so it's actually about mapping. So now I have to go find out why we haven't mapped the seafloor. So that's really where it started for me.
Okay, thank you. And I suppose for myself, I'm a child of the 60s and 70s where, Apollo was on, as a kid. Only one or two TV channels, and the sort of programs you tended to have were, either Cousteau, out doing his thing, or you had popular sci-fi programs like Voyage to the Bottom of the Sea and all this kind of stuff. And I think as a sort of 6 or 7 year old, when, Apollo 11 landed, in my case, you thought, well, it's going to be impossible really to become an astronaut, but it is kind of achievable to start doing, become an aquanaut of some kind, might be a realistic possibility. So, and there are huge overlaps between space exploration and ocean exploration, except space is much easier because there's only one atmosphere difference between the land surface and space, as opposed to one atmosphere for every 10 meters when you go underwater. So the people who want to do the easy work do space, and if you want to do the really cool stuff, you go into the sea instead. And one day, future scientists and engineers, possibly even people who are alive today, will be the people who build the robots or even go physically themselves to explore the oceans of Europa, Enceladus, Titan. So space and sea are going to be interlinked far into the future. And so I've just found it a really exciting field to work in. And going back to your point about people, it's also about the inspiring people, the terrific mentors you have in this sector. It's a global sector. People don't think in terms of national boundaries when you're looking at a space which is 71% of the planet's surface. You tend to work in multinational teams on multinational projects, and it does give you that wonderful perspective of how everything is interconnected. And also, of course, there's nothing quite like being stuck in a Southern Ocean storm to really give you a real perspective on your mortality and all of those kind of things. And I've had the honor of that as well, including, as I know, have many people on the audience today.
Yeah, thank you, Steve. Yeah, I know, Laura, you've also had that research ship experience as you describe in your book. I haven't, but one day, if anyone's got a spare, I'll come. There's a great question in the question and answer, which I will ask, but I'm going to take my chair's prerogative because I just want to stick with people for a moment. So my area of work is public engagement with science, and I do a lot of work trying to bring the scientific world to all sorts of different public groups. And I suppose this is a question that I too will do what Peter did and ask you both. It's like, Laura, you've written this book presumably because you want people to engage with this topic, but I'm just wondering, I mean, it's a great way for people to do that, but just wondering why you think that's important. And then likewise to Steve, with Seabed 2030, I'm very pleased to say in our exhibition here at Dynamic Earth, we've got a panel, we've got your map. It might need updating because it went in a few years ago, but we've got that map that is quite startlingly showing how little of the ocean we have mapped in detail, telling people about that project. But what value is it to you to have the public really engaged with this? So perhaps again, can I ask Laura first, then Steve?
Yeah, for sure. I mean, I thought that I was always attracted to the people who were behind the making of the map. So the map was important. It's obviously that's the destination. But for me, it was more about the journey, and so telling the stories of people who are behind the map. That's why I ended off on that quote from Dennis Wood, because I am quite romantic about ocean expeditions. And I think, probably anybody who's at this talk is probably also quite romantic about ocean expeditions. I love these stories of people setting off on journeys around the world, and they're not necessarily aware of what could come out of it. The possibilities are really endless. A lot of bad, a lot of good. And so that's really what it was about for me. And then just along the way, I happened to discover all these incredible characters that I felt were sort of unsung, hidden figures within the ocean exploration world. So I think we often hear about the James Camerons or the Victor Vescovos of that world, and that's wonderful. That we know these people, but at the same time, I also wanted to bring to light people who were sort of behind the scenes. I've also always been attracted to anybody who's sort of down in the trenches, doing the daily work of just like logging data. I really am attracted to those people just because I feel like they often think that they don't have a story to tell, but they've seen something incredible with their own eyes, gone off into these really remote places that I think would blow the mind of most ordinary people, but for some reason they've seen so much of it that they don't think it's special anymore. So I always love talking to those people who've been out into those, the middle of the Southern Ocean and been battered around, and they don't think they have anything to say about it, but they really do. They've seen incredible things.
Great, thank you, Steve.
Okay, did you want me to go on to start answering the questions that are coming in on the Q&A page?
Yeah, we could. I just really want to know. I just wanted, just before we go, I think Stephen Malcolm's asked a great question, but just this notion of you want Seabed 2030 to be well known, but why does it really matter if the public know it if they aren't able to be partners on your project? Why does it matter that somebody living in a landlocked country, for example, with no means to map the ocean, knows that Seabed 30 is a thing? Does it matter?
I think it matters totally. I mean, my now retired colleague Craig McLean in the States, he always used to say, if you're a farmer with a good weather forecast, thank an oceanographer. And he was absolutely right, because unless you understand what's happening out there in that nearly 3/4 of the planet's surface, which is water, there's an awful lot of things that happen to you in your day-to-day life living on land, even if you're thousands of kilometers away from a coast, which make no sense at all unless you have some awareness of what's happening out there at sea. It could just be your winter weather patterns. It could be what happened to the harvest this year, how much salt needs to be put down in your local highway. I mean, all of these things are related to what's happening out at sea. And of course, there's those other more profound societal implications, things like, homeland security, defense, all of those kind of issues as well. Many of us live in nations which are, protected by naval forces of various kinds, or we have to be aware of the threats. Only this week, there's been another incident of interference with the pipeline and cable network in the Baltic Sea, this time affecting Finland. And so when things like your internet connections start going down because somebody's been out there snipping the cables, or you find that you're not able to, eat fresh fish because somebody did an oil spill because the chart wasn't good enough and the ship hit the rocks. All of those things show why even a landlocked member of the public, it's worth them knowing something about what's happening in the ocean.
Okay, so let's definitely now move on to Stephen's question, I think, because it sort of follows on. Thank you. Mapping is often carried out with a view to exploitation. So what will the holistic ocean map allow us to do? I think, Steve, that's probably for you.
Okay,
you must come up in the context of Seabed 2030.
Absolutely. I'll start off and then Laura might have more to add. But okay, mapping. Historically, if we look at ourselves as primarily land-dwelling creatures, mapping, of course, was always a prelude to some form of exploitation, whether it was knowing where the best forest was to chop down the trees, or where the navigable rivers were, or knowing where the borders and boundaries of your kingdom was. Mapping is an essential human activity that helps us understand where things sit in relation to each other. If you don't have a map, it might mean that only those actors who do are able to carry out any form of activity. So you could turn the question on its head. Yes, mapping is often done as a prelude to exploitation. But if the only people who have the maps are the people who want to go out there and do the exploiting, they are obviously at a considerable position of advantage to, marine spatial planning authorities, general public, non-governmental organizations, those who might be opposed to exploitation. Those people will not have access to that map. A well-heeled company that's able to go out and do its own mapping will end up having a very high resolution chart of exactly the place where they want to do whatever it is they want to do. If the public don't have access to a map, how can you challenge it? How can you say, no, this isn't a good idea? It just raises 101 other questions. You could do a whole PhD dissertation, I'm sure, on the pros and cons of mapping, but I don't think the answer is not to map. It's certainly true you cannot manage what you haven't mapped, but if you haven't mapped it at all, you not only cannot manage it, you cannot form any form of understanding about it at all. Somebody could be completely destroying a fragile ecosystem and you would have no idea the thing had even existed.
Yeah, it's true. I mean, I think that question is one that I fielded quite a lot while I was writing the book, and definitely after publishing the book, it comes up time and time again, because as soon as people hear about anyone making a map of sort of a unknown or uncharted territory, the first kind of question that comes to mind is like, well, what are they going to do with that map? I think that that's a pretty logical place to go with it. And that they're not wrong. There's a big push right now to exploit the deep sea and open up the international seafloor to commercial mining, perhaps as early as 2024 or 2025. That's going on right now at the International Seabed Authority in Jamaica. And we're also kind of going through a period of industrialization in the ocean. We've sort of reached a point where a lot of the resources that we've taken from land are sort of maxed out. And one of the oceanographers that I interviewed for the book, he said, the future is offshore. And I think that's very true. I think that a lot of eyes are turning to the offshore world for where we can go next. And some of those aims are benign and some of them are less than benign. I think it's important to keep in mind that, like a map is really, you've probably heard this a lot, it's really a neutral tool. It really depends on what kind of motivations people bring to it. So it can be used for good or it can be used for bad. And the line between those things is not always so black and white. So you see industry and science kind of intertwined on a lot of exploration. But yeah, we're really at this turning point of like, you know, do we know enough about the deep sea to start industrialization? Are we going to protect this area? What are we going to do with this map? And so yeah, really, it remains to be seen. But I wouldn't like to see exploration of the deep sea stop because there's concerns about exploitation, because there's incredible things down there. When I was on one of these ocean expeditions, at one point we were pulling up like forams, foraminifera, and just these incredible little creatures that are sort of look so pretty underneath a microscope, like kind of like twisted tulip bulbs. And, you know, they're hundreds of millions of years old. And I'd never seen them before. And I don't think many people have seen them before. And I would be quite sad if people didn't know about foraminifera and, you know, how they're working and living in the world. And so I think that really comes from people being out there and exploring and having like that insatiable drive to understand our world.
Understand our world. That's a good segue here for Gwyn, who has asked this question. We've been accustomed to maps with many layers, not just topography on land or bathymetry under the sea. Those on HMS Challenger did map large-scale sediment distributions, for example. Where are we with mapping other layers and relating them to bathymetry and seabed features? And I just wanted to say that Tina Bishop and I have been working with the In Search of Earth Secrets and the International Ocean Drilling Program, who have amassed a significant number of cores of ocean depths, and so that's sort of that's my experience of layers, and it would be interesting to hear from you, Steve, on what Seabed 2030 is doing about sediments and 3D, potential 3D mapping, and also from you, Laura, on I know that Cassie and the other ladies working on the mapping were looking at how echoes came back and how they could determine what was what. Anyway, Steve, and then Laura, perhaps.
Okay. Well, first of all, the GEBCO map, the General Bathymetric Chart of the Oceans, which is what Seabed 2030 exists to facilitate. GEBCO is purely a surface topography or bathymetry map, so it's mountains and valleys and that kind of thing, and not to very high resolution either. The people who go out there gathering the data that gets contributed, that feeds into the GEBCO map, are often gathering considerably more data and at much higher resolution than the things that we use in the case of GEBCO. Now, we excuse me, we don't throw away any of that data. It's all there, in the metadata, and being kept at the the relevant international data centers. So I suspect what will happen is in future, GEBCO may evolve into a more comprehensive product that starts having these additional layers of information as well. But of course, the information that's out there through eModNet and through all of these other initiatives that exist, it's possible. You don't have to be at this kind of lowest common denominator area of the GEBCO chart. There's absolutely nothing to stop any other entity going ahead and adding data layers, KML layers, whatever it is you'd like to be able to do. So you could say, what GEBCO gives you is the baseline map, and then everyone, the world, is welcome to start adding all those other layers. There's nothing in the GEBCO map about biodiversity, ecosystem types. It doesn't even go into the details of what kind of soil you're finding there at the bottom. Is it clay? Is it sand? Is it gravel? That stuff isn't on the GEBCO map. So the information is there, and in time, I'm sure will get added into all manner of multi-layer maps.
Yeah, that's an interesting question. I kind of approached this through one story in the book, where I was blown away at one point in the book when I discovered just how much seafloor used to be land. So when the last ice age glaciers melted, thousands of years ago, all these coastlines got drowned. And Florida, as probably many people know, it lost roughly 40% of its land mass. So since the last ice age. So there's, a huge amount of coastal areas around Florida that used to have human habitation there. And to kind of go back to this additional data that's contained inside maps, for years and years, underwater archaeologists had been trying to use sub-bottom profiling to pick up on where buried artifacts were in the sediment. And so at first they were using sub-bottom profiling to just like echo down into the sediment. And they were like, oh, we can't see the artifact. There's nothing there. But more recently, a group that I went and worked with in Florida, they realized that the hint of where the artifact wasn't contained in the sub-bottom profiling sounding. It was actually an echo, a sort of signature that was creating this kind of haystack effect in the water column above where the artifact was. And all they had to do was go back through seismic soundings that have been done in that area by oil and gas companies for years. And they could start to identify all these places where lost human settlements were. And so we went out into the Gulf of Mexico and we were going around with a sub-bottom profile and we dove like 18 sites, and like every single one had human artifacts there. So
Wow.
There's just like a treasure trove of data that has all these really incredible discoveries still locked up in there. And like we haven't even started to go into those areas. And the farther offshore we go, the further back in time we're going. So we were really just at that coastline area, really close, only a couple kilometers offshore. You go like 8 kilometers offshore, I don't know, you're going back thousands and thousands of years. So there was a lot of incredible things that are still locked up in all those different layers of data.
Wow. Thanks so much. Now I'm conscious of the time, so I'm just going to ask a sort of final question before Peter wraps up. We've had a note in the chat. Let me just scroll up. This just came to us, but it was saying there was an interesting statistics from Deloitte that the US spend in 2019 on, I think, marine exploration or marine mapping was a mere $219 million, whereas it was $21.5 billion on space. So no further details there, but clearly we've got a massive order of magnitudes difference in investment. And I thought I might just merge that with the final question that's come in from the Q&A. Stephen Malcolm has said, is sufficient attention being given to managing the consequences of any new knowledge as we discover more? Knowledge is essential, however. But, what does this sort of massive difference in investment and what we're doing with all this new knowledge sort of have to say? Perhaps some final comments from you both. Laura, do you want to kick off first, and then Peter will wrap up after you, Steve?
Yeah, no, I think it's no secret that I'm really on Team Ocean here. So I think that money on the ocean side should be raised. And yeah, I definitely agree with Stephen's point that, I think that there should be, in our quest to sort of figure out the world and figure out how we fit into it, I think that there should be more oversight and there should be more money and attention paid to regulating what's done with this knowledge, because this knowledge belongs to everyone. CBID 2030 is creating the first publicly available map, and it should, it's available to any scientists who want to use it. And that kind of project really attracts me because it's there for everyone. But at the same time, you do need some sort of questions being asked about where all this knowledge is going. And I don't think that we've quite gotten there to the point where people are asking, how can we regulate this information? What should we do with it? Where is it going? So I think there's definitely always a part to be played for somebody to kind of ask those higher level questions. And yeah, so I agree definitely that more attention needs to be paid to that.
Yeah, and I'd further that the the whole area of ocean policy and governance is one which is gradually creaking into action. I mean, for many, many years, UNESCO, for example, which hosts the Intergovernmental Oceanographic Commission, only spent 2% of its budget on ocean. And recently that was raised to 3%, with a lot of argument. You know, people sort of saying, why should it go from 2 to 3%? You know, this is for over 70% of the planet's surface. World's 5th biggest economy, you know, is the ocean, but it has no seat at the UN. You know, there isn't a permanent seat on the Security Council or anywhere else where somebody sits up as the spokeswoman for the ocean. So clearly there are big issues there. And if you're fortunate enough to live in a country that has a marine spatial management system, you know, which are just beginning to come out. You know, in the UK we have a marine management organisation. There are similar kinds of things in other countries. If you have that, you're at least beginning to take the baby steps in having decent ocean governance. But even where that applies, this only goes out to your 200-mile limit. Once you go beyond that 200 mile, you're still in the Wild West. So although the UN has recently passed some new policies on exploitation of marine resources in areas beyond national jurisdiction, we're a long way from that being anything like global ocean governance. And there are so many escape clauses. You know, you could just register your company in a country that hasn't bothered to sign up to the UN convention. What are the actual legal, what are the tools you can use to actually enforce anything? Very, very hard. You know, do you send warships in to chase somebody who's doing an illegal activity? You know, is it over the top if you sink somebody that's doing something bad? And we haven't, as a collective culture, really got our head round yet about how do you police these things, how do you govern them, and how do you make all of the information available to the whole world.
Thank you both very much. And thank you, Hermione, for co-hosting and helping me out here with this technological challenge I've got. Big thank you to Laura and to Steve for spending time putting all this together and the slides and summarizing it so well. It's really part of the idea of these conversations is to have an hour where we spark conversations and things to think about for future conversations that you can all have, and maybe we'll come back to it. And I think we've done very well with that today. It's really super. So thank you all very much. Our next conversation is going to be on the 14th of December on a really controversial topic, perhaps, the minerals from the sea. So we'll look at what the Challenger did and what's going on today with all of that. And maybe that'll be a bit more controversial. Wait and see. We're going to take a break in November so that another colleague can... There's a Challenger event in Greenwich, England, called Beyond the Ocean Depths, revisiting the Challenger expedition. That's on November the 7th and 8th at the UK National Maritime Museum. And we hope to see you in December in the next Challenger conversation. Thank you all for attending. And again, thank you for Hermione for helping out here and co-hosting, doing a great job. Thank you all very much indeed.
Thank you. Thanks, Steve. Thanks, Laura.
Thanks, everyone.
Bye all.
Take care.
Okay.
Oops. She gone. Where did she go? How do we get